Okay, this is the second question. This is a tabular question. It's talking about concert tickets that went on sale at time t equals 0, and at different times it tells you the number of people waiting in line to purchase the tickets. Notice it tells you it is a twice differentiable function. So what that means is that the second derivative exists, which also means that the first derivative exists, so it is also a first differentiable function, which also implies that this is continuous. So this is a continuous and differentiable functions. The first question says, use the data in the table to estimate the rate at which the people waiting in line was changing at 5:30 p.m. So I want to know what happens at 5.5. So in order to figure out what happens at 5.5, I need to use the 2 points that are closest. So I'm going to use these data points here. So the rate, or the slope, would be 150 minus 126 over 7 minus 4, which is 8. And units are people on the top, hours on the bottom. This is a 2-point question. 1 point is for the 8, 1 point is for the correct units. Okay, part B, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours. So first of all, anytime you see the word average, you should be thinking, I'm going to do 1 over 4 minus 0, from 0 to 4 of the number of people waiting in line. But I'm going to use a trapezoidal approximation to approximate this integral right here, since I don't have an equation. So the trapezoidal approximation is, area of a trapezoid is 1/2 times the height times the sum of the 2 bases. So I'm going to need to do this over the interval from 0 to 4. So my first trapezoid is going to go from 0 to 1. So my first trapezoid is 1/2. The height is 1 since I'm going from 0 to 1. The 2 bases are 120 plus 156. Plus, my second trapezoid is going to go from 1 to 3 now, the second 2 data points. So it's 1/2. The height of that trapezoid is 2, and then 156 plus 176. The last trapezoid is going to go from 3 to 4. So 1/2, the height is still 1, 176 plus 126 from my data table. So this gives me the approximations for this integral, but I want the average of this, so don't forget to put that 1/4 in front of everything. So this is your trapezoidal approximation. If you punch this out on your calculator, you'll get 155.25. Units should be people. It's a 2-point question, 1 point for showing this, and then 1 point for the actual value with the correct units on it. Okay. For 0 to 9, what is the fewest number of times where the derivative has to be equal to 0? And give a reason for your answer. So first of all, if the derivative is equal to 0, I know that it means that there is a local max or local min or a horizontal tangent. So I also know that L is continuous from 1 to 9 because we knew this was a twice differentiable function. So I know that when I look at these data points, there's no holes in between. So if I look at my data points, you should notice that between 1 and 4, I know this is going to be a continuous graph, but I know somewhere between 1 and 4, because the y value goes from 156, then up to 176, and then goes down to 126. We don't know that 176 is the highest point on the graph. It could be 200, like at 3.5. But I do know it does come down eventually, so I can say because the function is continuous, it is important that you state that there is a local max somewhere between 1 and 4. Using the same idea, when you look at the table, you should also notice that there is going to be a local min somewhere between 3 and 7. And then same idea, there's another local max between 4 and 8 somewhere. So there are 3 values. At least, there may be more, we don't know, but there's got to be at least 3 values where L prime is equal to 0, because these are the 3 places where I identify local maxes or mins, and you must state that it is continuous. This is going to be 3 points. You got to show me your reason, you got to state that it's continuous, and you got to tell me that there are 3 values. Okay, the last question. The rate at which tickets were sold is modeled by this equation. This is tickets per hour. I want to know how many total tickets were sold by 3 p.m. So if I integrate the rate from 0 to 3, that will give me the total number of tickets that were sold. Use your calculator. And I want it to the nearest whole number, so round it to 973. 1 point for this, 1 point for this. This is a 2-point question.